Alright, so the last thing that we're going to do with inverses and determinants is a process that will let us solve a system of equations. So for right now, I've got a very easy equation up here that we could solve a substitution or elimination, but I'm going to show you two other methods that we can use that will be easier depending on the size of our system or the size of our matrix. So the first step, we're going to first use the inverse of the coefficient. So you guys are pretty good with inverses at this point. We're going to create a matrix of just the coefficients. So that is 1, 1, -3, -2. And we know that this matrix times an unknown matrix is going to give me the solution set. So the -4 and the 14. At this point, this should look just like the equations that we did when we were working with our inverse, because we know this is really some matrix times an unknown matrix equal to a third matrix trying to solve for x. So we would divide by a. Technically, we can't divide matrices. So that tells me that x is equal to the inverse of a times b. So we could find the inverse of a, multiply it by the -4, 14. We've got what our x and y values are. So then if we do that, 1, 1, -3, -2, I'm going to go ahead and put the identity on the end. The 1 is taken care of. So then we're going to have to turn the -3 into a 0. So I'll say 3 row 1 plus row 2. 1, 1, 1, 0. That gives me 0. That gives me 3 plus -2, which is 1. And then we get 3 and 1. Then the last thing that we have to do is turn this 1 into a 0. So we're going to do negative row 2 plus row 1 just to keep this as a positive 1. 0, 1. I'll move this up here in a second. 3, 1. Now if I do -0 plus 1, I get 1. -1 plus 1, I get 0. -3 plus 1, -2. -1 plus 0, -1. So there's my inverse right here. And if I take my inverse, let's see if I can move this up, and I multiply it by the solution, so -4 and 14, we're going to go across by down. That gives me 8 minus 14, and then -12 plus 14. We end up getting -6 and 2, which in this equation we know -6 is my x, 2 is my y. There's the solution to that original system of equations. Now it's not the easiest, it's not the fastest, but it is another method that we can use. Last method that we can do is Cramer's rule. And what we're going to do, we're going to start in a very similar pattern. We're going to take the coefficients, 1, 1, -3, and -2, and we're going to create a matrix with those guys. And then off to the side, I'm going to create another matrix with the -4 and the 14 with my solutions. Now, first step that we always do is we find our determinant. So that's what I'm going to put down here, D. So we've got -2 minus -3. My determinant is 1. And there's two steps that we're going to do. We're going to then find the determinant in terms of x and the determinant in terms of y. So I list this out every single time before I start the problem. In order to find the determinant in terms of x, we're going to replace the x values with my solutions. So what we're going to do to that, let's see, where can I squeeze this in? Instead of writing 1 and -3, I'm going to write -4 and 14. My y values will stay the same. And we're now going to find the determinant again. So it's quick. 8 minus 14, we get -6. And then if you could look ahead, the determinant in terms of y, we're going to replace the y column with my solutions. So this is my dx. dy is going to be 1, -3, and then -4 and 14. So you just have to be careful that you replace the right column. That gives me 14 minus 12. We get 2. And then the actual answer to solve your system, in order to find x, the x value of this system up here, you take the determinant in terms of x over the determinant. So that's going to be -6 over 1, which is -6. That's exactly what we found down here. And then to find y, same process, determinant in terms of y over determinant, 2 over 1, which is 2, exact same thing. So I think Cramer's rule is a little bit quicker and a little bit easier as long as you can remember. Now, for a 3x3, I would definitely pick Cramer's rule because you would have 3 rows and 3 columns, and your answers would have 3, so it would be an extra number in here. If you're trying to find the determinant in terms of x, replace the x. determinant in terms of y, you replace y, and then for the third variable, z, we would have a determinant in terms of z. We would replace the z column with my solutions. So it is no harder if we are trying to find it with Cramer's rule with 3 by 3.